Hey there, geometry students, Mr. Rising here. This lesson 10.2 in your book, if you're following along, is all about circles as far as their circumference and area, introducing the concept of leaving things in terms of pi, and then dealing with regular polygons, which is a tricky thing, and you have to pretty much use trig in order to figure these things out. You'll notice that this lecture is only 3 slides, and again, I'm going to try to keep it right to the point. Long ago, you learned that the circumference and area of a circle, the circumference is 2 pi r, right? And another name for twice 2r, twice the radius, is the diameter. So again, the circumference, you can think of it with a diameter of d and a radius r. Circumference is equal to the diameter times pi, or twice the radius times pi. Also, the area is pi times the radius squared. And here's a great little example to go with it. Now, you're going to start seeing problems that really need to be precise. So maybe up to geometry, you were using 3.14 for pi, and sometimes in Khan Academy it says, well, just use 3.14. But pretty much now, for the rest of your mathematical career, you are going to actually use the pi button on your calculator or your phone. You've got a pi button right there. And when you do calculations. And then sometimes a problem may say, find the area of circle A, this little symbol means circle A, in terms of pi. So it wants you to leave your final answer in pi, okay? And then it gives you a problem. So let's just do a couple of examples, and we're going to go into some depth while we do it. So the first one says, find the area of a circle in terms of pi, in which the circumference is the quantity 4x minus 6 pi meters. Okay, my 2 rules from the last session were draw a picture if needed, right? And pictures are helpful. Or 2, use the formula you need. In this case, we're trying to find area of a circle, and so that's pi r squared. All right, well, in the problem, I was given the circumference. Okay, so circumference, let's see, I can even just use this formula right here. Circumference is pi times 2 pi times r equals this. All right, and now what I need to do is try to get r all by itself, so then I can use it in my area formula. Well, to solve for r, I have to divide both sides by 2 pi. You'll notice anything divided by itself is 1. So pi divided by pi is 1, and then 2 goes into, and that becomes 2x minus 3. All right, so now I figured out, oh my gosh, that is one ugly radius, but the fact is it is a radius, and I can use it, right? So there's my radius, whatever. Well, now I'm going to plug it in here. So I'm going to say pi 2x minus 3 squared. Now, if possible, if you could leave your answer like that, that'd be fine. If they want you to FOIL it out, I'm sure you have the mathematical skill to FOIL it. This would be 2x minus 3 times 2x minus 3. And I would FOIL. And I still have pi. Right, so first, 4x squared, outer, minus 6x, inner, minus 6x, and then lasts. There we go. Plus 9, and we get 4x squared minus 12x plus 9. Holy cow, pi, and that would be meters squared. That's the area of that circle. That is a big, ugly problem, but that's kind of some of the problems you're going to have to start facing. The next problem is much more simple and straightforward if you can identify what it's asking. It says a drum kit contains 3 drums with diameters of 10, 12, and 14. Find the circumference of each drum. Let's do it 2 ways. First of all, let's find it exactly. Exactly means in terms of pi. Wait a minute. circumference is pi times diameter. So that means the first one would have a circumference of 10 would be 10 pi inches. That's it. The 12 one would be 12 pi inches, and the other one would be 14 pi inches. Because remember, they've given me the diameter. All I have to do is multiply that by pi. I'm going to take a brief moment just to show you that I can also do that on my calculator. If they say, well, round it to the nearest hundredth. So I could say 10 pi on my calculator and then just hit enter. Right? And that's 31.42. Inches and so on. And I could do that for each one of the problems. Now, the next thing we need to talk about is regular polygons. And just to recall, a regular polygon has all the same side lengths and interior angle measures. So let's just review a couple, some vocabulary. N refers to the number of sides. Right? In this problem, there has to be 1, 2, 3, 4, 5. In this example, there are 5 sides. S is the length of each side. The central angle, you find it by taking 360 degrees all the way around and dividing it by the number of sides. In this case, that's 360 divided by 5, which is 72. I'm trying not to confuse my 360 divided by S and my 360 divided by 5, but in this example. The radius would be, for example, CF. Let me put it this way. From center to corner, vertice. Okay, so that would be like CF or CE. Those lengths right here are those yellow lines are radiuses. Apothem, or the little letter A, means from the center to the side. So this is an apothem. Let me write that out. Center to side. And again, you'll notice that is shorter than from the center to the vertice or the corner of the triangle. Last but not least, how do you find perimeter of a regular polygon? Well, you take the number of sides and you multiply it by the length of each side. And if you were trying to develop a formula for how to find the area of it, well, you'd say, wait a minute. It's triangles. I just add the triangles together, all right? Well, area of a triangle is 1/2. The base would be the side length. The height would be the apothem, right? So that would be one triangle. Let me highlight that so you can see right where I'm talking about. I'll use the purple. So I took like this triangle right here, zoom. And if I did that multiplied by the number of sides in the figure, n, I would get a formula like this. Now, you'll notice just in the step before, we said the perimeter is equal to the number of sides times the length of each side. So really, our formula is now this, 1/2 AP. Now, let's do an example problem of how this works. Again, I've got my formula up here where perimeter is the number of sides times the length of each side. Again, when you're given a problem, think about your formula, step 1. Think about a picture, step 2. So let's take this picture and label it. It says find the area of a regular octagon. Octagon means it has 8 sides with a side length of 4. So these are all now 4. and there are 8 sides. So by the way, now I know this number right here is 8. Okay, very good. Number 2, find the central angle. All right, well, the central angle is 360 divided by 8. Now I've included the next step in it as well. And it says take the central angle and divide it by 2, and I'll show you why. And then I'm going to take that answer, so that's going to be 360 divided by 8 is 45. And then I'm going to go divided by 2, and that's 22.5. Here's what I'm going to do. I'm going to draw that triangle right here. So this angle is 45. But what I'm going to do is I'm going to take that triangle and I'm going to split it in half and use trig ratio SOHCAHTOA to figure out either the radius or the apothem or whatever I need. So let me just take this triangle, and I got a bunch of them, right? Each one's like that. I'm just going to zoom it over here. I'm going to go, whoosh. I've got 4. I've got boom, boom, boom. I've got this one is 45. And now, when I split it in half, this part of my angle is 22.5, which came right from here. See, now I'm dealing with a triangle, and it's got a right angle in it. So now I've got a triangle that looks like this. 90, 22.5, and this length is now 2, which was I took this one, and when I split it in half, I went from 4 to 2. So now I can use some trig ratios. Basically, I have almost everything I need, right? I know the length here is, each side length is 4. The only thing I need to figure out now is A. In this case, the apothem is the hypotenuse of that little triangle I just drew in red. So this one right here, I'm sorry, nope, let me back up. It's the height of the triangle that I just drew in red. So it's going to go right here. All right? So if I'm thinking about this picture, if I'm standing in a 22.5 degree angle, I know the opposite side. I'm looking for the adjacent side. So we're going to say the tangent of 22.5. Oh, let me go like this. Tan 22.5 equals opposite 2 over A apothem. And again, this is coming from this picture right here. Let's finish solving the problem. I realize this video goes long. It's a long process. I get, these are going to switch places. I get A equals 2 tan 22.5. 2 divided by tan 22.5, and that's 4.83. I'm at my final step. Use my formula. I can now plug this in for A. So I get A equals 1/2 4.83 8 times 4 is 32 times 32 divided by 2, and the area equals 77.25 centimeters squared. That is a big, long, hairy problem. I'm not going to give you a bunch of them, but you'll need to know how to do it for the next chapter, and it's one of your standards you're trying to learn now.